We're good. Thank you, Floyd, for again having the Zoom facility open up for us. We'll continue on with introductions. I see some new people on here that I haven't seen before. Chuck N0NHJ, can you tell us where you're at, Chuck, and how did you find out about us?
Good evening. Yeah, I'm over in Glenwood Springs, Colorado, so I'm a ways further away than most of the folks, but ran into one of the Bobs up at the Hamfest back in August. I want to say up at the Adams County Fairgrounds, and he talked me into signing up, and it sort of sounds like an interesting project. I'm hoping to get some time to get down there and see some of the stuff one of these days.
All right. Well, thank you for joining us tonight. You must have got did I get you on our email list or did you get it through DSES?
Yeah, I actually get it twice. I signed up for the groups IO and I got it the other way also.
Okay. Yeah. Okay. Yeah, I see on the list here. Okay. I just didn't not recognize your call, and I didn't recognize Glenwood Springs as being one of our members. We got people scattered all over the state and all over the country. And speaking of which, we have Burton N6UG joining us again. Burton's out in somewhere in Northern California, Sacramento area. What's the name of that town, Burton?
Hey, look, now it's not muted. Can you guys hear me?
Yes, we can.
Yeah, I'm in a place called Rockland. It's about 25 miles northeast of Sacramento off of Interstate 80.
And Burton's recently joined. I talk to Burton a lot on 40 meters every day, and he has a great desire to come out and see our site sometime, probably next summer when we do maybe an open house or an EME event, or maybe even during the EVE project. So
maybe, yeah.
Kind of quasi-professional photographer as well. So he does some great photos of wildlife and other things there, and sporting teams. So thanks a lot for joining us, Burton. I see Rob up there in Idaho, a former resident of Los Animas, Colorado, who used to go to Haswell site, DSES, and drink beer under the 60-foot dish when he.
Don't forget about the underage part.
Okay.
You just had to be a member.
Spent more time out there than we ever have. So.
Yeah. Well, I still feel guilty about the broken beer bottles, but we'll work on that later.
All right, Derek Brady, you're located up in Northern Colorado?
I'm actually out in Hudson, so not quite northern, a little more east of Denver, though.
Okay, east of Denver. Okay, yeah, I haven't recognized you. And what else we got here? Anybody else want to speak up that I haven't recognized yet? Chuck, and I already talked to you, Chuck. So let me see what else here. Let me see. I guess that's all the new people we've seen here. So feel free to speak up if you have any questions to anybody in the group tonight. We'll get started off here when I flash the quick flash of the agenda here, and we'll let me see. Trips to the Flischner site. We've had multiple trips the last several weeks. And we'll talk about some of the ones that deal with dish elevation issues and the dish feeds. So since Glenn Davis, Lewis Putman, and Phil Gage are our gurus who have done all the software and servo installations and made our dish. So when we know it's pointing towards Planet X out there, we know it's Planet X and not Planet Y somewhere. So go ahead and take it away. I'll share here, and if you need to share. Well, if I can unshare, okay. You can go ahead.
I didn't put any slides together, so.
Okay, so that's fine.
Okay, so basically what happened is last week sometime, Lewis and myself went down to Haswell, and we really had two things that we wanted to get accomplished. We wanted to look at the elevation encoder issue, and then the second thing was to look at some mount characteristics of each axis. Let's talk about the elevation axis issue. I think what everybody's been seeing essentially is when the system comes up, the elevation axis for some reason is showing that the mount or the dish is over the top. In other words, it's pointing in the opposite direction where it should be. Let me talk about how that system comes up, and then I can tell you what I saw, and then maybe we can talk about how we go forward with this and fix this problem in the future. So basically what happens is when you walk into the tower and you turn the power on to the system, all the stuff upstairs in the pedestal gets powered. That includes the Raspberry Pis, that includes the switch that talks to the encoders, and that switch provides power to the encoders. So when that happens, basically the encoders come up, and since they are a client type object in a network sense, they come up and they're ready to be connected to. So then what happens essentially is when you go down into the facility and you bring up the Raspberry Pi software, it comes up and then it immediately connects to the two encoders. And then once those two encoders are connected, then the status is returned, or the position data is returned from both the elevation axis and the azimuth axis. So the time period from when you bring the power up into the tower to when you bring up the Raspberry Pi could be minutes, it could be hours. It doesn't make any difference. Those encoders come up as servers and they're ready to be connected to. Now, what I saw this past week when I was there is that when I brought the system up like I normally do, the elevation encoder did what we've seen in the past. It basically said that the mount was pointing over the top and pointing backwards compared to where it really was at. I noticed at that point that there was an encoder position of 0. Now the encoders are used to actually come up with azimuth and elevation. So if you have a 0 encoder position, it may or may not be in the range of values for position data on the elevation axis. And really what happens was when it does the conversion, it comes back with a bad value. And basically it's not communicating. So you can't really do anything with the elevation axis at that point. So I was watching it and I was trying to figure out, okay, so how am I going to approach this problem today? And before I had a chance to go out to try to clear it, either by moving the RJ45 connector and God forbid, getting into the back of the encoder box, it cleared itself out. So within probably 30 seconds to maybe 2 minutes, it cleared out. I wasn't really keeping track of the time. And after it cleared out, the system ran totally fine the rest of the day. So that's one thing that I've seen. I know at the moon bounce, people had to go out and actually go in and take the back off of the encoder box up in the tower, and then maybe connect and disconnect and reconnect the connector before we got communications between that encoder and then the Pi that runs down in the facility. So that's something else we've seen. So we've been seeing this flaky kind of problem going on off and on since we did the installation of the encoders. I'm not real sure if I saw it when we did the first installation this summer, but it certainly has been occurring probably since then in the September, October, November time period. So we're kind of, Lewis and myself are kind of at a loss as to what the problem is. Oh, I forgot one other thing that's important to this discussion. When we did install the cable for the elevation axis, it got damaged when we were pushing it through the conduit. The RJ45 connector got damaged. So what we had to do is we basically, once we got it through the conduit, we had to cut off the RJ45 connector and put a new one on. Then we basically put it back in, and then the system ran fine after that. So there has been damage to the connector, and we put a new connector in, but how well we did, how well it's crimped, all those things could be a factor. But unfortunately, that kind of goes against the other problem where people are actually changing the connector on the back of the encoder and not the connector that's going into the switch. So those are two things that are a little bit confusing to us. So after much discussion about what we should do, we really think probably that we have to get a new cable. Now, getting a new cable means that we have to go through the same process of running it through the conduit. And I don't know if we've added more stuff into that conduit since when we installed this summer, but there wasn't much room at that point when we pulled that cable through it then. So when we do order a new cable, we're going to have to be very careful about not damaging either end of the connectors to make sure we don't have an issue. Now, when Lewis bought that cable originally, basically he went to the vendor and Lewis looked and saw that the vendor could only provide a cable that was up to about 5 meters in length, and we need one much longer than that. So Lewis talked to the vendor, and the vendor basically said, find a commercial, Ethernet connector for power over Ethernet, buy that, and that should work fine. There's nothing special about the connector on the back of the encoder that would require you to use one of our cables. Lewis specifically asked that question. So now we're at the point where we think we probably should buy a new cable, and we think we should go ahead and install it as soon as we can or as quickly as we can during the holiday season. I'm not sure when we'll get down there again. So that's kind of where we are with the elevation. So I don't know if anybody has any questions about the elevation.
Yeah, Glenn, can I make a couple comments?
Certainly.
Because the day before that you were there this last week, I had this problem where when we tried to put the dish down into the service position on the service tower,
Right.
the elevation encoder was not reading out. So on the Raspberry Pi on the console, we're not getting any elevation reading.
Right.
So we went ahead and we, eyeballed it, tipped it down to the service position. While Ray and Roger were working on the feed, I went up and tried all the connectors and everything and didn't get a reading. And so I took the back off the encoder on the encoder box.
Yeah.
Unplugged the encoder cable, which is a little 4-pin, kind of a 4-pin DIN connector with a screw on. It's not an RJ45.
Yeah. So it's got
And that's very custom connector on there, and plugged it back in. And then I climbed back down and I got a encoder reading at that point where that seemed to fix it. And we did the same thing when we were down there with Alex. Alex and Ray went up, did the same process, and fixed it during the EME program.
Right.
So in my view, anyway, we've had this happen about 4 times. And in each case, it seems to be removing the connector on the back of the encoder and plugging it back in is the solution.
Right. Now I have had multiple times where if I reseated the RJ45 connector on the switch to a different socket or a different plug-in, that also cleared it. And see, that's confusing as to what's going on to me. So, but to me, it sounds like we should get a new cable and at least try that.
Sure. And what you mentioned in the beginning, is there a sequence of operations that we have to turn on one system versus the other?
Well, the only thing you really need to be careful about, and this is what you would do anyway, is as soon as you got there, you would turn the power on to the tower. As soon as you do that, that powers up the switch, and then that powers up the encoders. And the encoders are sitting there in the state of waiting to connect until the Raspberry Pi in the facility is brought up, and then it connects. Now, if you don't do it in the right order, it will connect anyway. It will just show errors on the console, but ultimately it will connect. But if you're looking for the exact right way to do it, you can go in, turn the power on in the pedestal, go into the facility, turn the Pi on, they'll connect immediately.
So pedestal first. So we haven't necessarily been doing that.
Oh, you haven't?
No.
Ah.
Not every time. I mean, it's by happenstance.
So if you don't do that, then like I said, it probably will connect eventually, but you'll get errors until it actually does connect.
Do you think that what you're doing when you unplug and plug, that you're actually resetting the encoder?
Yeah,
Possibly.
Quite possibly.
That's possible.
I think that may be what's happening, is it's confused and then you're resetting it.
Exactly. But I did not understand that you weren't bringing the tower up first.
Well, I could not tell you for certain that we brought the building up first, right?
Well, that's why I stepped through it this evening.
Yeah.
So you understood that.
And I do know that when we were having the other issue with hanging Diane, we were powering the tower off and back on. Every time it would hang, we'd power the tower off and back on to reset Diane.
That would probably cause a slight issue. There'd be a time period where they're out of sync, kind of, and then ultimately they would reconnect. And that would be true in the case that if you didn't bring the tower up first, there would also be a time period where it's trying to connect, like maybe once a minute. I think it's more like every 15 seconds or something like that. But there is definitely a handshake there. I mean, it's just like, connecting to a site on the internet. That site is a server. Your PC is a client, and you're trying to connect to something somewhere else. If that client or if that server isn't up, you'll just get errors. You'll never connect. So It's the exact same thing. It's the exact same protocols, TCP/IP Internet protocols. So the
Okay.
thing to remember is to bring up the tower. But even so, Bill, we never have this issue, at least as far as I can tell, with the azimuth encoder.
That's true. Azimuth doesn't.
And they're essentially the same device.
Right.
So
I'm wondering if it's an absolute encoder, right?
yep,
So it's got some kind of a power on boot, some kind of a boot.
it's got some kind of
routine.
computer with a
Yep.
network interface.
Yep, exactly.
And it's PoE
it-
too. So any noise on the system could affect it, but it's a PoE
Right.
cable running up
Yeah,
there.
no, but it may be having to go through, and we don't know how long the boot sequence takes.
Right.
Actually, I do. It's relatively quick.
Oh, it should be pretty quick. Yeah.
Yeah, I had both the encoder and the cable as a tool or as a materials that I use for doing development. So I had that same cable, that same encoder and switch at my house when I did the development.
I have
Okay.
another data point, Glenn.
Okay.
When we had this problem on the EME on I believe it was Saturday night or Saturday afternoon, we reset the switch and everything in the console
Okay.
with the tower running, and it did not clear it. And Ray and Alex had to climb the tower and unbolt the thing and unplug the cable and plug it back in.
Which switch are you referring to? The one in the facility or the
The
one?
one in the facility, the one in the building.
Yeah.
And so
It
I guess
should
it could hang because it's being powered by the PoE switch in the tower.
right.
I guess once it hangs, it could hang, and then you'd have to clear that.
Right.
But it seems to me that we tried both things. We tried powering the tower down. We tried powering the console down. We tried all the sequences, and it did not fix it. The only thing that fixed it was them going up into the tower.
I mean, quite honestly, Bill, the azimuth axis was acting flaky just like the elevation. Then I'd say there's something there, what you're discussing. But the azimuth axis never has issues. It's the exact same device.
That's why I think it's the cable.
Exactly. So, Louis, did you want to talk about what you think may be going on with the cable?
Yeah, I just had, can everybody hear me?
Yes.
There was one other issue I'm slightly concerned about. We wanted to clamp that cable inside the elevation box, but we ran into issues with trying to do that. So basically there's a clamp on the cable to keep the cable from dropping back through and down the tower, but it doesn't prevent movement. So I was a little concerned that when that as axis turns, that it twists the cable some, and then that in turn translates to twisting the cable inside the elevation axis. It's
Maybe, but
So-
you've got at least 18 inches of slack in a loop inside the elevation encoder box.
right, but the twisting could cause that to move around potentially.
Yeah,
But
potentially.
that's just, I think we need to anchor it anyway. I'm not necessarily
Well,
totally convinced that that's the problem, but that's.
for no more than the new cable costs, I think we ought to just put another cable in and go from there.
I agree.
Well, I would also, one comment on something you made earlier about that connector being proprietary in there. It turns out that is the connector that all the industrial types use for Ethernet connections. And one particular benefit of it, it's waterproof. So if you have something that's exposed to that kind of environment, it'll protect it from that. So actually, in truth, I think it's a better connector, and it is standard for industrial type equipment. So
Okay.
yeah,
So it's only 4 pins.
right. It's those encoders. I think they run on 100 base T Ethernet. They're not gig E.
No.
So they don't need more
they don't need the full complement of lines to do that.
Okay.
So I agree with you, Bill, that we should probably go ahead and maybe get the cable ordered. You know, it's $70. It's not that big a deal.
Yeah, we've spent a lot of time climbing up in the tower, and taking it apart, and it's
Exactly.
well worth $70 for. I'm just.
And I gotta be honest with you, you know, working up that top of that tower this time of year is just colder than you know what. So
Yeah.
especially with the winds blowing. So let me talk about the other half of what we were
Good.
doing down there, and I'll do it real quick, and then we can just move on. But basically, Lewis and I were going down there, and we're looking at how we can improve tracking and improve not hitting the brakes on elevation and azimuth. So, you know, basically how the system works is there's a relay that there's a relay that enables it. And then there's voltages that actually drive the motor. So until that relay is enabled, the voltages don't make any difference. But the way our software works basically is when we stop it, we turn the relay off and then the brakes fire. And that's true on both axes, I believe. So if you listen to it, that's something Bill's always been somewhat concerned about, is he keeps hearing what he believes, and I believe too, is that the brakes are firing. And we probably only have so many of those in the lifetime of the system. So do you agree or disagree, Bill?
Yeah, that's not what I was complaining about. What I was complaining about was that we're driving the system. The accuracy, you've got well more than enough accuracy.
Right.
And what I was concerned about was that we're driving it too often. We don't need more accuracy. We need less accuracy. We need the moon spot to move across the field of view and let it go all the way to the other side and then drive the motors. I don't care about the brake. I think you should leave the brake to fall in, because that's what saves us from wind and that sort of thing, so we don't freewheel. But I think that we're way too accurate, especially with the 16-bit encoders. We're down to driving where we used to drive on EME about every 2 minutes. We're driving, depending on where we are in the orbit, we're driving, you know, like every 15 to 40 seconds.
Right.
And so we're putting a lot of wear on everything that we really don't need for the accuracy. You're too accurate.
Okay, so
that's my complaint.
Okay, so what we're looking at basically is how to keep our accuracy or maybe improve the accuracy. And I'll tell you why in a moment. But also allow that we go maybe back to the 2-minute thing with lesser accuracy, and then let the operator decide what they want to do.
Yeah, that would be ideal, is if you could define the field of view, or define the drive spot where you are in the field of view. That would be the ideal situation, is there was a parameter we could set depending on which feed we have installed. Right.
So that's what we're looking at. And so based on that, what was driving us to go down there is we really wanted to look at how slow can we command each axis? Can we command 0 rates? You know, those types of things. So we're looking at that to figure out how our algorithm would determine how and when we turn the power onto the motor and when we turn it off.
Yeah.
So that's what we were looking at. Now, the one thing we discovered when we were down there is that the elevation axis has a minimum rate. And that was the odd thing that I mentioned in the memo. You cannot command the elevation axis rate to less than 0.05 degrees per second. The only way you can go to 0 rates is to basically turn it off, which means turn everything off.
Yeah.
So we were looking at, and so that's why we went down there, and that's why we were looking at data. So once again, this all feeds into tracking accuracy and how often we engage the motors.
Yeah, that's what I'm after, is try to reduce the amount of time we're engaging the motors.
Okay, and not only that, we're looking at how can we make it feasible for someone who's chasing Venus to be accurate enough to ensure that we're staying on Venus, versus how do we chase the moon and we're accurate enough to do moon bounce? Because those are two different things.
Venus is easier than the moon. Ask Ray.
No, Venus is harder than the moon because you want to stay as accurate as possible because its trajectory changes over time.
You have to stay ahead of it too.
Yes. You have to be more accurate when you're going after Venus. If you want to keep the signal higher.
Okay, but let me just say this. One thing I noticed, this is kind of backing up a second.
Okay.
The elevation rate is fine. We're driving the elevation down and back up in the stow and all of that, and that seems to work fine and it's quiet. What seems to be happening in the azimuth is we've got the rate commanded so low that the system sits there and the motors are stuck and they're buzzing, and it makes a tremendous amount of noise in the azimuth axis. And so that's one thing that I'd like to see us not do is try to command the azimuth at a low rate. And that's all the more reason to have more time between actuations of the system.
Right.
And there again, that would reduce the accuracy. But if we did the math and we look at everything on Venus and the moon, you got way more than you need because of our beam width. And there just isn't any reason to go tighter than what we already are. And in fact, we're already too tight.
Okay, well, I don't know the math for if you're off the center of the dish or not. That's something that's beyond what I know. But if we get too far out, to me the signal level go down, and we're sending a lot of power. We're sending some power to Venus. It changes on the way there and on the way back. So that's my high level understanding of what happens.
Okay.
So if we don't collect, the correct amount of energy, we won't see it.
Okay.
Is that correct?
Well, within the, like 0.8 degree beam width, if we can keep Venus within the 0.8 degree beam width at 1296, or at 1296, that's all you have to do. And because Venus is not counter-rotating to our orbit, it actually stays in one place better than the moon does.
So if I put Venus on the dish somewhere near the lip, it's going to produce the same amount of power, or we're going to
No.
the same amount of power.
No, it's 3 dB down at our beam width. So at the 0.8 degree beam width,
Okay.
that's where we drop off 3 dB. So you look at it and it looks like a haystack, and come down 3 dB, that's where the beam width is measured. Right, Ray?
Yes,
Jump in on this.
yes,
Yeah,
it's,
that's correct.
And so we just have to keep it within that. And if we can stay within that, that's great.
So Ray, you feel comfortable if we're within 0.8 degrees of Venus, then your signal will be appropriate?
Yeah,
Actually,
we stay
0.4.
within 0.4, right?
0.4, yeah.
Yeah, that is a 3 dB beam width. Now, you could say you wanted to keep it within a 1 dB beam width, and that would be much less. But that would be asking too much. I don't think we've got that kind of precision in our drive mechanism and in the wind or anything else on the dish. So I think, realistically speaking, the 3 dB beam width is what we should stay within. And it doesn't, the same accuracy for the moon as it is for Venus.
Okay. That's what I needed to hear. So, but I'll keep looking at it because I think we'd still need some kind of variable thing to let the operator decide what they want to do. So
Yeah, a selectable thing would be the ideal case.
yeah, so we'll continue down that road, but that's where we're at right now. So just a quick summary. Myron, we're going to go ahead and buy another cable.
Sure.
And we're going to continue investigating how we can do this, allow the operator to pick how accurate he wants to be.
Okay.
Okay.
Maybe, yeah, maybe we're up in the tower working, but it's a whole lot warmer in the building.
That's for sure. It was so nice to work in the building.
Fantastic working conditions there for you guys.
Definitely.
Yeah.
Thank you very much.
Okay, well, thanks, Glenn and Lewis. And is Phil Gage still actively involved with your effort there, Glenn?
Most certainly, he just doesn't do meetings. And he doesn't do meetings more than about 2 people. So,
Okay, understand.
so Lewis and I and Phil, that's the max for Phil.
Yeah.
There was one more, he wouldn't show up. So that's just how he is.
Oh, good. Well, I'm glad
But
he's
he-
actively involved.
But he's really great. He works, when we give him something to do, he's really good. So,
yeah, the 3 of you guys doing a great job.
yeah. Okay. Thank you.
Bet. And Ray, what do you have for us now that you were down there earlier this last week and did some feed change out?
Yeah, we installed the 250 megahertz feed antenna, and we did some other cleaning up, and the preamps for it are not, excuse me, mounted on the antenna. They're mounted in that little white box up on the side, the little plastic box. And so all of that's set up in there. It's really kind of nice. That's why I designed it in the first place, to house the preamps on ones that weren't real critical as to the length of cable between the feed and the preamp. But so I think it works beautifully. It's got about 50 dB gain worth up there, a little more than. So, and at that frequency, there's a little less loss in the cable, quite a bit less loss actually. And so we have very strong signal down in the building, and putting the spectrum analyzer on it, we can see the noise level come up, and all the way across the pass band of the filter that I have up there. So now, from now on, we have to change the feed antenna, but we wouldn't have to change that preamp assembly. We would only have to change the antenna and match it with a matching filter between the 2 preamp stages. And so that's kind of a neat system. We can move frequencies around a little bit, but I really hope that we can get down there fairly soon and actually look for Jocelyn Bell's pulsar down at 250 megahertz and see if we can get that, because that'll be the lowest frequency we've used the dish, and pulsars get better at lower frequencies. So I'm looking forward to picking up a number of new pulsars now.
Yeah, I'd love to get a good strong pulsar there. I hope to be able to go down next week. I'll let you know.
Oh, very good. Thank you.
And also from Glenn's discussion, chasing a pulsar is different than bouncing a signal off of the moon or Venus. So for pulsars, we'd love to be in the 1 or 2 dB range of the peak.
Yeah, I was gonna say, with respect to pulsars, it's not like you pick an offset and you get a steady signal. What happens when you let the antenna drift is that the signal level varies. So that varying of the signal, I think, on a pulsar, could potentially reduce the detection sensitivity of the thing, because it introduces some noise, varying signal levels on the pulsar, and it could drop below the noise level and then come back up. So it may end up looking kind of like scintillation in that case.
Yep.
I was going to ask you, Ray, I think you already mentioned it, why you chose 250 megahertz for the feed this time around, which is something we've never done before.
Yeah, and as a matter of fact, I'm kind of amazed when I looked at it with the spectrum analyzer after we had everything done. There's quite a bit of junk in there in that frequency band. When I looked before off of just a disc cone antenna or anything, there was nothing there. And a military aircraft band is really basically from about 225 up to 400. And that's not used by too many other things around. And so I chose that band because we don't have that much military activity down there. And not only that, those are discrete frequencies, and we can usually handle those with the interference elimination routine. So I chose that as give it a try there. If you go down below that, you run into possible some TV stuff, but you run into a lot of other garbage below that frequencies, and even above 400, you run up into the a little bit on the ham bands, and then you get into the television, which is at 470 and above on the UHF television bands. So I chose 250 because that would stay away from the 220 megahertz area where there is some junk and give us about, 20 to 40 dB with a beam width or bandwidth, excuse me, up there. So 250 was just the lowest I could go and still be away from most of the interference. But I'm surprised, and that the interference that I did see, I think, is coming from our site. But we haven't proven that yet. But we certainly are going to look at that.
The military frequency, aircraft frequencies from 225 to roughly 400. And primarily most of the frequencies I ever operated flying helicopters for the Army was between 230 and 260. Most of those frequencies is what we used. I do remember the Special Forces SATCOM back in the 80s and 90s used 265 plus or minus 5 to 10 megahertz for their FM SATCOM communications, their little portable setup they'd set on the ground and talk through the satellite to other parts of the world. But I'm not sure if that's still in use now, since the technology has changed on that. But yeah, you never know what's going to be. But down where we're at, down that area, there shouldn't be much except overhead military aircraft transiting, maybe talking once in a while. But that should be pretty quiet down there as far as that goes.
I would have thought so, yeah. And they would not normally bother us that much because we can eliminate them, disregard those kind of signals.
Yeah.
But yeah, I'm seeing the same kind of noise at 250 that I've seen at other frequencies down there, and I'm pretty sure that we're generating that ourselves. And so we're going to have to do a little soul searching in the next few weeks here.
Okay.
So, Ray, we tried turning off the heat pumps and the lights and all that in the building, and we didn't turn off the switchgear, but everything else was off. The computer was still running on the table. One of the questions I had was, what did Jocelyn Bell use? What was her frequency?
81.5 megahertz.
Oh, big antenna.
Big antenna. Yeah, acres. So.
Yeah. Well, those VLA antennas have 75 megahertz on them. Thereabouts, or 78, something like that.
Yes, they do.
All right. Anybody have any questions for Ray? And Dan, let us know how things go next week if you can get down there.
Yeah, and I need to get with Rick. He's got both of the B210s. He was going to do some comparisons, so I need to get a B210 from Rick before I go down there.
Okay. Yeah, Rick was excited to hear that we're going to do more radio astronomy work. So that's good. So before we head on to any more questions, before we head on to Alex, the EVE 25 project, our chief engineer.
Yeah, Myron.
Yeah, go ahead.
Well, go ahead. Let's let Alex in, and then I want to talk about elevation force coming up.
Okay. All right, you can do that in the drawing segment there. All right, Alex, you ready?
Yeah. Everyone hear me okay?
Yep, hear you fine.
All right. Sorry for my voice. I kind of got sick yesterday trying to survive. So this is my first time I'm streaming from my lab, which I'm working on the projects because I kind of got married with EVE 25 system for the last couple of days and been spending a lot of time here. So I want to give a brief update where we at. Well, good thing we're moving forward, not backward. That's a good thing. And I'm happy with where we at right now because I had a lot of concerns when you have a design in your head and on the paper, it's different when everything is on the table in the way and the shape and the form you expect to be. So I've done some testing already, and some systems are fully functional. And moving forward, I'm still waiting for some parts to arrive. They kind of slows me down a little bit. I'm trying to find something I have here while I'm waiting for the main parts to arrive. But so far, so good. So if we're gonna take the whole assembly and whole project, when I had that Excel file showing everyone a couple of weeks ago, we're around close to 65% of completion, which also includes the testing phase. So hardware unfortunately takes a lot of time, especially drilling and tapping, and you have to be very precise and accurate to make sure you're not going to break a tap in a place where you can go back. So I want to show what we have right now. So I'm going to switch my camera so everyone gonna observe what the EVE-25 system look like. This is the first time I'm going to do that. I'm going to switch the camera. So this, and you guys, if you have any questions while I'm talking and showing, please interrupt me and ask a question. So this is the main unit, so-called the transmit unit. That's the most heaviest one. I barely carried this with my two hands. It's about close to 70 pounds because there's a lot of metal there, and the power supply and SSPAs itself, they kind of weighed a lot. So it's mandatory two-person carry because there's no way one person can handle. I'm just barely moving from table to table. That's all I do. I'll add some Sora handles, so easy for transportation and moving around. But this is a unique design and a unique system. I think one of the kind, I don't think that anyone ever amateur radio built the system that capable do 2,000 watts of 1296. So I'm really looking forward to the system gonna fire up. I'm pretty close. I just finished wiring up today the control systems and insert the temperature sensors, because protection is essential for me, where I make sure that we're not going to find ourselves that the system going to burn or like SSPA. First of all, they are located in a very easy access and convenient place. So if we do need to replace them, all we need to do unbolt all these screws and it all comes out. So it's a very easy. I didn't bury them under the metal, so that's kind of easy to in case if something goes wrong. It'll take probably an hour to replace, but it's capable to even on the feed as well. So I added some temperature sensors right inside the heatsink. It's about 5-inch inside. I drilled a hole into the temperature sensors for each heatsink. So a real-time temperature monitoring, and have 8 sensors in total. This is the outputs. During the test phase, what's going to happen in a few weeks, we're going to be testing each amplifier separately until we get the nominal measurements and the calibration for the power and protection. And then we're going to add the combiner and the combine. I'm waiting for the driver amplifier right here. That's going to be mounted, and I'm going to drive these 2 big amplifiers. That part didn't arrive yet. So that's only thing I'm missing, the part to complete the whole assembly. The last thing I'm going to do is a combiner. Yes, there's a lot of fans in there because we want to make sure the cooling system is capable. Each power supply has own built-in cooling system, as well as a protection, which I'm going to utilize the protection for each power supply directly to the control unit. And two fans are controlled by temperature sensors, so they're turning on and off when it's needed. And the other 2 are turning on only when you transmit. So when you on or receive, there is nothing turned on as long as the temperature stays below a certain amount. So this is the main unit. I made this chassis on top so we can slide other boxes right on top of here. If in case if that won't fit, because the whole assembly is about 18-inch, if that won't fit in a hub, then we're going to use those boxes separately. So any question about the TX unit?
Alex, we could use those temperature sensors for monitoring as we get close to the sun. We can see how we're doing when we track close to the sun.
Absolutely, because I have 8 sensors provisioned. So I'm going to use probably no more than 6 for the assembly, because I want to measure temperature of the each amplifier itself. I want to measure the temperature coming out of heatsink, and also so-called exhaust, and also the input, which is the ambient temperature. Those are essential. so we can calculate. By the way, I also have a relative humidity sensor, so we can calibrate it to specific amount, because I don't want the humidity going to rise at certain 90% or 80%. Am I going to cause a problem with electronics that is not protected? So the system will shut off this each of the power supplies and amplifiers automatically. I'll talk a little bit about the monitoring and system a little bit later, but this assembly is unique because it has real-time monitoring, telemetry, and as well as protection. Protection is sophisticated. You have multiple layers of protection. My goal is to protect the investment, so we make sure we operate, and then whatever happens, it will protect itself. So I'm probably going to have 2 additional sensors reserved for anything we needed. We can place them. They are like here. They're like this. So this is the temperature sensor. So the sensor is inside in a shielded enclosure. So we can place somewhere we wanted to measure. We can do real-time measurements. Any other questions about the transmit unit?
Can you identify where the power supplies are located, where the transverter will be?
The power supply, we were talking about inside the hub?
No, where you have them physically on, right? You identified where the where the amplifiers were, top and bottom. Now, power supplies are located on each side of the package.
That's correct. Yeah, the power supplies are on the side. Because
what's the current?
60 amp each one capable. Each amplifier maximum consumption current is about 50 to 53 amps at the maximum power. We don't need to run on maximum power. Well, I calculate just a little bit more just in case if we need to supply, but we're probably going to be running about 40 amps on each side.
What voltage you running on the amps?
Voltage is 50 volts. 50 volts. Each has on. That's kind of smart too, because in case if something happens, let's do the worst case, one amplifier goes damaged or power supply, we have a full redundancy because we can still operate one unit. Or we can switch the power supplies to another one and run the unit. So everything is switchable as a matter of switching the lead from one to another side. So I made a maximum allowance so we can repair in a short period of time without significant impact to the design. So the power supplies are located on the side because it's the weakest part. They can't hold the weight. So initially I thought it was going to be on the bottom, but they can't have the whole weight on top of them. So I place them on the outside and I put the rails on the bottom protecting the SSPA. And as you can see on the side, the rails are protecting the internal. So if it fails on the rail. And I can add more angles on each side to sort of like protect. I don't think it's going to survive. It's going to fall from the hub to the ground, but we should avoid that happening at any cost. But from falling to the ground is maximum protected. And when I'm going to install, because I don't know where going to be the combiner, I will also add some rails, so it's going to protect. But every time I add any metal, it increases the weight. So I also want to make sure we're not going to put something that doesn't really need it. So everything is ready here. I finished the wiring today. So let me show on the side. This is the control box. So as you can see, all cabling. By the way, every single cable is shielded. I don't want to take any chance of self-interference can occur inside. So every single sensor differential and also shielded. Shielded cable go to the main box. So all this connection is going to happen here. And you have 3 connectors going to the control, which includes telemetry, protection, the signals, and everything in there. I just need to wire up the control cable for the power supply. So I'm going to turn it on and off each power supply individually from the software, as well as using the internal protection signals to my system, so to make sure the system is healthy prior we're going to engage transmute. And in case if something happens, the alarm signal and emergency shut off happens within 20 milliseconds. This is very essential
This is better than any mechanical relays can give us. So it's all based on the MOSFET transistor. So in case of high SWR, high temperature, unexpected low or high power, everything triggers system. What I also did included system, because guys, remember, it's a lot of power capabilities. With our antenna, again, we're going to generate 80 million watts as estimated isotropic power. So it's a very big concentration of energy and power density in 0.8 degrees beam width. So we're going to make sure we're going to transmit. Nobody will allow outside within the antenna. So I'm going to add the buzzer, which is going to indicate sort of like alarm, going to be audible from in our side anywhere, so we know that the system is engaging and give people alert that the system going to be on. So all those provisions already incorporated in the system. Any other question about a transmit receive? Transmit unit?
Yeah, Alex, you said that if it didn't fit for any reason, you could remote part of it. What was the part you could remote? The power supplies?
Oh, no. This whole thing will fit no problem. This is essential thing. And I made it specific way, Bill, that it will fit in the hub. So we just need to think how we're gonna mount it. So we need to have sort of like a rail so we can slide into the hub and kind of keep in the middle of the hub. So kind of like create a CG somewhere in the middle of the feed assembly. This whole thing will fit, but if I'm going to attach other boxes on top, that might not going to fit. So that's why I added this rails here. Either I'm going to attach the system, that's mainly for bench test. So if I do bench test, everything is a one unit. All cables attached to each other, you just apply the power, the AC power, and you're good to go. But in case of the assembly, I made maximum the way so we can use different configuration, put on the side, put horizontally. Even control box could be mounted outside somewhere plastic box, because it doesn't need to be inside a hub. It has only control and monitoring in a low voltage DC power supply, but no RF. I need this box to be close to the antenna feed as possible. And that's the idea for Ray, because this is going to be faced towards the feed. And here we're going to have the combiner, the final stage. They're going to combine these two power into one, and that's going to connect using one of those Helix cables to the feed itself, looking like that. So that face should be close as possible with transmit port on the feed. So this is faced towards the feed point, and that would be faced towards the cover. Now, these fans are sucking the air and blowing here. This is the only way we can maximize the temperature, the cooling system, because I need to take hot air outside, not inside. But I still need to have enough cold air on the back. So that is my concern, because depends on the elevation. Let's say on the 45 degrees and higher, the hot air, because the whole system is going to be pointed upwards, the hot air going to be trapped on the top, which the fans are. So, and I don't know if this gonna would be sufficient airflow. But the worst case, what we can do is, if we're gonna remove that plate that we have, and we're gonna install or just leave it open, or put the mesh one in there, so that will allow the cold air coming from the top of the hub. But that's only if we have a good weather, no rain and no high wind with the dust. So that's one of the options we can do to make sure. But I don't know where we're going to be running the EVE 25, at which elevation, Venus elevation, we're going to be actually attempting. So that's still open conversation. Any other questions about this system?
Is an air filter necessary to keep dust out of there, or would that just reduce your airflow as well?
Well, there is possibility that we can remove the screen and insert something like this that I have it here. So it has a filter in there, so that will keep all dust. It's like in the computer systems. So it's easy to install on each one because it's exactly the same diameter. By the way, that can be done without any impact to the system. You just remove 4 screws and install that filter in there, we're done.
Where's your transfer, your LNAs are gonna be at?
So LNA would be mounted right at the feed in the same way as you can see here.
Okay.
So this is the feed. It's identical to the one we're going to be building, but you're going to have just slightly bigger 716 connectors. So the idea behind is going to be metal box attached to the feed with the relay and isolation relay and LNA in it, and it's going to be connected directly to this system. So I'm slowly going to move to the RX. So this is basically
say Alex. So
Yes.
you asked about the elevation. Next March, when we're doing this, Venus will be coming up around dawn. It'll be up all day and then set in the evening. So it's going to be kind of like tracking the moon. You'll use all elevations.
Okay, so good to know. And we'll also need to look on the forecast weeks ahead to see what options we have. My concern only at a certain elevation where we're going to be already running and going to have kind of heat generation, the whole metal. It also depends on the ambient temperature, obviously. But I want to make sure that the hot air that's going to be trapped without any possibilities to, because hot air is lighter than cold air, is going to be accumulated in that corner where the fans are. And it's going to blow the same air circle back and forth that might going to compromise the temperature characteristics of the system. So to avoid that, we can just remove that the cover that Ray normally puts on the back, and that will solve the problem. But I'm also make sure that this system is securely mounted inside. We don't want to find ourselves in a worst nightmare situation where whole thing slides out and flies out of a hub and it's done. So we're make sure we'll find this, because I don't have ideas yet, but I do have a rails on the bottom, and there are 3 of them attached, so they're kind of like a very heavy and robust parts. So we can attach sort of like a chassis, so we can mount that sub chassis to the hub, and we can slide this in and bolt it down, or use some clamps. I'll let Ray and Roger think about this, but this is heaviest part and must be inside in the middle part of the hub. There are no other options for us. This cannot be located outside. We can't compromise our RF power. It should be in a relatively close distance to the feed, so we can maximize our power at the feed. Any other questions?
I have a question, a legal question, not an engineering question.
Yeah.
The maximum power we're running is more than the normal legal limit for ham radio?
No, it's a 1500 watts. This is
Okay.
our goal to generate, but doesn't mean the system should meet 1500 watts. We can have 2000 watts capability to overcome the possible losses. The reason system designed that way, because we don't know what loss is going to be, especially having a combiner and the cables and the connectors. So to make sure when we're going to connect all system, we can supply amount of power that the equivalent of 1500 watts at the feed per legal FCC regulations. But also each amplifier itself is about 1200 watts. So we estimate about 1800, 2000 watts coming out, which we can always reduce the power by adjusting driver level. That's how I'm doing. It's called programmable attenuator. So I can control it from the software, so I can choose amount of power going to the amplifiers. Another thing also, the temperature characteristic, because we don't want to run amplifiers on 100% duty cycle, especially running Q65 for 3-4 minutes. So to make sure the amplifiers are relaxed, they're running about 60% or less duty cycle, with the provision adding more power when needs, because when temperature raises up, the power drops due to efficiency. Any other questions?
You said you got to drive it with 20-watt amplifier, which will go on the side there.
All right. The F40 amplifier going to be here. It's going to be coupler here. It's going to be programmable attenuator, so we can control it and choose the right attenuation. The reason I'm doing this, I don't want to climb up and down every time. I want to have everything fully controlled from the computer. So that's why I'm going to add that, and we'll control this from the software. So the 20, it's enough to reach the maximum power by reducing power of the driver amplifier or terminating so-called ALC, out of limit control, same like you have an HF radio, will limit the amount of power going to the SSPS. So this is the inputs right here. They're going to be connected to the hybrid splitter. It's going to be mounted on the side, and that's how we're going to control the output power.
Is that a Kuhn amplifier, 20-watter? Did we?
No, it doesn't generate enough.
No, I'm saying, is that a Kuhn brand, Germany?
No. It's one from the Netherlands. Remember what we ordered? That one did not arrive. It's a small module about this size, about an inch tall, and about 2-3 inch in length, but that part didn't arrive. It's going to be mounted on the side. That's I'm waiting to finish the wiring, and as soon as it arrives, the system going to be ready for power up. I'm going to power the power supplies first to make sure that they're turning on and off, and I have a telemetry coming down before I'm going to fire up because it would need 220 volts. I don't have 220 volts here, because they're not running out of 110, they're running on 220. There's no way to have 50 or 60 amps on 110. So we need two-phase for that, and that's why we're bringing two-phase up to the feed. Any other question about that? So I'm going to move forward another 2 units, 3 units actually.
Go ahead.
All right. So it should, because this one is the most essential and kind of complicated, so we spend a lot of time. It's worth it. This one not complicated, so it's made in a sub chassis. So this is just a carrier with some connectors. Everything is unplugged. You can unplug and the whole thing comes out. Very easy design. We have two. I think you guys remember I mentioned that we're going to have provision to have 13 centimeters and 23. So they can do 2 transporters. They are fully switchable. So they both feed 10 megahertz reference. They're also switchable by IF. So I just send the command from the shack and can switch to 13 to 23. The reason I'm doing on this system, so in case if you're going to design a 13 centimeters amplifier, there's both units going to be controlled by the same unit. We don't need to design anything beyond the power amplifier. So this is a dual bender, has all identical controls, and that's what is all wired at RF2, the main system, as well to the shack and the control system. So very simple design, nothing extraordinary. 10 megahertz. Splitter 3, so I have extra 10 megahertz coming out, and the one feed it to one and another one. I have control, and we're going to have some low DC voltage regulators and everything, all the matter of wiring this things up. So that can be done anytime. I'm not worried about this. This is low priority for me. The top cover goes on top, and this whole thing is mounted this way. So you can connect everything directly to the system during the test phase. Any question about this unit?
When we were talking about developing the system, Alex kicked around the 23 centimeter one, and the discussion we had with the group, EVE group, considered going to 13 centimeters, 2304. but what we planned on was 1296. So we decided to go ahead and put the capability for 13 centimeters in that box, and it's minimal cost to do that in the overall project. So it wasn't really that much extra coin to add the 13 centimeter 2304 megahertz.
That's correct. And we have also LNA systems. So we're going to have LNA assembly, and we have the transporter. Only one thing we're missing, and we had a lot of conversations about that, is the amplifier. There's no way to find 1.5 kilowatt amplifier for 13 centimeters, and that's kind of
I think the biggest one makes about 250 or 300.
Yeah, exactly. And then 250 watts that I found that we actually can buy, but in order to reach 1500 watts, we need at least 6 of them combined, which kind of overcomplicates the system. It's going to be a lot bigger than this.
Yeah.
So the solution is either to have TWT amplifier on treble wave tube, but unfortunately, they're not around, and the commercial versions there are costs about the twice more than the amount of money we got for this Eve project. So it's absolutely unreal for us to do that. But in case if we'll find a way in the future, we'll come back. We'll have 13 centimeters already implemented. We'll all need to build the amplifier. Everything else is ready. And that's my idea was behind it. Let's put this low-cost part now. So we will have that, and we don't need to redesign the system. These two systems will stay identical. The only going to be changed is just amplifier, which is going to be additional amplifier to it. Any other question about this system? All right, so this one is the cool system. This is unique system. I call this control box. If you remember in early stages of proposal, I had a block diagram of the entire system, and I kind of distinguished 3 main systems: the transmit module, the receive receive IF and transmit transverters called RF unit, and the control unit. My concern was about choosing the right and designing the right control unit, because all of that controlled by a single unit, which comes to the computer. I'll demonstrate right now everything, just giving the idea. So that was a last minute design for me, because I didn't know how I need to put all these things together. And I look in my shelf and I find the right size box. I said, there we go. So I immediately design a whole system. And this is the main unit for us, because it's the brain of entire EVE25. So it has the power supply 27 volts, which steps down to 12 volts. It's all here. And there's 2 voltages distributed to all systems. We need 27 volts to drive the driver amplifier and some of the fans. And as well as the 12 volts to supply power to our receive system, and as well as the other modules we have here. So the main unit is so-called REPAM. It's been designed in Denmark. It's called PA Control Unit. It's open source, and you can do whatever you want with it in order what your purpose is. So we've got this unit, and it controls everything, collects the data from everything, and we have everything. What I added to it, I added fiber optic. So imagine that everything controlled by fiber optic. And this is the fiber optic cable. This is what we're gonna be having from the feed to our shack. This is only one connection. Well, there's 3 connections. The one is RF, because RF does not come through this cable yet. There are options, but it's all about the money. I don't want to spend money on that. We can use traditional ways supplying RF through our coax cable, which is low level, 28 megahertz. We don't really care. It's a piece of cake. And the PTT control line that also can be done here, but I want to make sure we have a separate line for PTT. So that's it. No video, nothing. Everything goes through fiber optic. We just need to use the proper connections. And this is the box, fourth box. This is inside a shack. It has SDR radio on it, which you're gonna use as a additional auxiliary SDR receiver. So we're gonna have two simultaneously receiving signals. One through the main system using ICOM 75, and a second just on the SDR. That will allow us to look at the wide spectrum using QMAP 65 software, so we can look at the entire spectrum. That's why I don't really care about Doppler. The signal can come in anywhere, we can decode it as long as it falls within wide bandwidth of this receiver. So we'll have this is the SDR receiver and IF line coming down to the shack, as well as a fiber optic. And then you'll have a LAN connection to your switch, which all your computers are connected. Very simple. I added provision to have a secondary fiber optic in case if we need to increase capabilities without redesigning. All we need to do, drop another module in there, and we're going to have a second fiber optic line, completely independent. That will be helpful to have 13 centimeters or any other additional bands from the same system without spending money on entirely new system. So I just want to demonstrate. So this is the module that's going to be inside our shack, just wired by using fiber optic cable. I think we do have already fiber optic. It doesn't matter what, as long as we have a proper connectors on the end. I'm going to flip the switch on the box. So right here, it's powered on. We have some fans going on right now, and we have some LED indications. We have some LAN communication. We have a fiber optic on, and we have a system on. As soon as I flip the system power switch, it's automatically connected to my software. So I already monitoring the system. I just, for demonstration purposes, I put the temperature sensor. I have two of them attached currently for testing purposes, and I can see them right there. As you can see, it's reading 24.6 degrees, and the other one is 24.87. So as you can see, there was 8 of them, and then we'll have separate name for each one, so we know which one is which one. All this data telemetry, such like current, RF power, as you can see here, your forward power, your reverse power, and as well as the SWR efficiency and the current. So we'll see all this in real time, as well as the relative humidity. Because I have power supplies are remotely controlled, we just click on this button, and it's going to send the signal to the system, and it turn on both power supplies on. So in idle, we're not going to have anything powered. Everything is controlled by the software. So we'll have instruction for operator how to operate all of that. And we have some indicators. In case if we have a high SWR, it will become red. It'll become red. It will trip the system off. And we're going to sound alarm outside the system in protection mode. In order to remove that protection, you just need to uncheck the button, and system is reset. No more running to the pedestal and flipping switches off, nothing. It's all in here. So we have all the power measurements. We'll have as well as fan control, so we can turn on and off fans or set them at specific temperatures. As well, we have reading such voltages. So I'm going to be monitoring 27 volt, 12 volts, each of the power supplies, statuses. It'll give me the statuses here. So am I healthy or not? And then I'll turn all my system on and off. I even can turn on and off here a signal source. So if you're going to place a signal source, we can activate on and off. I have provision of 8 switches to use external. That's our relay output. So you can wire up everything you wanted. One of them going to be one big buzzer outside indicating that we are running signal. So as I mentioned, everything is programmable. You just go in the settings and program everything you want it. That will be done when the system going to be fully assembled. I will define every single parameter in a way as a system designed. So we're going to make sure that no matter what happens, the bird, the rain, or something short, everything goes in the fold in a blink of an eye. So this system is meant to be protecting the most essential 2 boxes, which is SSPAs. Everything else, we don't technically care. But if you're going to lose one of these, we're pretty much down. So anyways, as you can see, this is the whole EVE 25, still in development stage. I'm kind of on the fly modifying things I designed. That's why I wanted to build everything here so I can change design accordingly. So not going to be something that something is built, it won't work. As soon as I finish the system, it'll go to the test phase. As you can see, this one module already done. It's fully functional. As soon as I finish wiring up the sensors to this box and defining the pinouts, I will define pinouts over here. I didn't finish that because I don't want to define any pinouts until the system is fully wired. So this goes first and then goes next. And then that is the last one. But all the system is fully functional. It can be shipped for testing, and I'll work on the feed and LNA. So we still have plenty time. We have more than 2 months to finish design and testing. All of this I built in 6 days from scratch. So that's what will give you the idea. All right, any questions about software, control module, and fiber optic?
Totally amazing. 6 days.
Yeah, well, I'm really excited because this is one of a kind system in the world that amateur radio person built for the purpose we're intending to do. So if everything works as designed, I mean, that's pretty much what I'm looking for. So that's why I'm putting a lot of time into the protection and everything else to make sure we're not going to lose in the first flip. The only concern I have as a design engineer is the combiner. Combiner is the weakest part. I want to make sure that there's no commercial combiners exist, unfortunately. This is pure custom design. I have to come up with solution. I have a preliminary design, which is based on this rectangular square tube, aluminum, which is going to have a solid rod inside. I mean, everyone's familiar with that. And there's going to be 2 ways. You're going to have 2 connectors on each side and then 1 in the middle. So that could hold 2,000 watts, but that has to be proved yet. So when I get to that phase, we'll work on the test phase. But this whole system will be tested as a separate amplifier. I want to make sure that everything works as expected with all protection layers before we combine the power. That would be the last thing what we need to do to generate our ERP what we need. All right, I guess I'm done here. More technical information come yet because I need to work on the drawing and design package at some point. As soon as I finish design, that would be implemented. But right now, I'm still flexible to move things around. So that's my low priority right here.
Okay, Alex, one more thing. Alex is the chief engineer. He lives in Chandler, Arizona. So all this is being done in his QTH in the garage. And he said it's much cooler in there now than it was during the 110-degree heat this summer. Paul, N0T is the VP marketing and also board member. He is the chief guy in charge of the overall program. Alex is the chief engineer. And we have a cadre of 8 or 10 folks on email thread that keeps track of things. If we need to throw comments around or suggestions, we can kick that information around. So if you want to join that, if you we got a lot of talented people on DSES, get a hold of Paul, and Paul can get you tuned in on the right email thread to make sure your input is also is available to everybody on the thread. We've gotten a lot of suggestions over initially, not much in the last couple of weeks, but we are open for comments and suggestions as we go on this project. Being a one-of-a-kind project, I think Alex is doing a phenomenal job of getting this thing started. I'm only involved in writing checks and paying the bills. We had to order a bunch of stuff from Germany. We had some custom issues, held up things for about 4 or 5 days. We had to pay about $250 worth of customs and processing fees to get that stuff cleared of customs. Everything is usually delivered directly to Alex's QTH. A few items came to Colorado Springs and we had to reship them down to his QTH. So that's how we're doing the buying of all these parts. Any comments? Paul, do you have anything you want to add?
No, I was just thinking back to the time when the board met and we discussed this project and you know what it would take to make it happen. And I'm like amazed at what we've gotten so far. So
yeah,
there's no way back, Paul. There's the only way forward. So we gotta finish it. And I'm doing my best, even I'm sick and I'm still here. And I was doing fixing things. And I want to bring one thing, want to make sure is also important part. And we kind of discussed that outside, Paul, about the weight. The system is heavy. So I estimate entire system, included feed assembly and the feed lines and everything, close to 100 pounds. So someone has to work on the analysis or at least something that we can do to make sure that putting this weight at the hub, we're not going to apply structural stress to the struts, or possibly we need to use a counterweight. So getting system to the feed probably would be option having lift. So scissor lift, so we can bring that system in safely without climbing the scaffold, because I don't think they're going to be safe. And those kind of subsequent questions need to be worked out in parallel with assembly. So, and I think I'm going to delegate those to you, Paul. So you've been working on that already. So make sure that the crowd knows that there are some things that needs to be done. And as well, I think it's worth to mention that you've been working with the Mark about the other station of volunteering to participate in project. So you can drop that since it's a part of E25. And I'm good on my side.
yeah, we've actually been speaking to the folks in the Netherlands that have the 75-foot dish, and they're interested in participating with us. I'm not apparently, and I think Mark is on the call. Mark, are you there? Maybe he dropped off. I don't know. It's anyway. Mark had indicated to me. Oh, there he is.
Hi there.
Hey, Mark. You mentioned to me like the dish there that you're looking at. You're still looking for other dishes in Australia to be our one of our receivers.
Yeah, I sent a few emails, but haven't come up with anything at the moment. Probably not going to find anything here in Australia, to be honest. But hopefully that list I sent you might have a few candidates.
Yeah, as far as I understand, there's only there's very, very few privately owned dishes. The only other one was our size is the one that's actually there's two of them. There's one that's in New Jersey and at Princeton, and the other one is in the Netherlands, and that's a 75-footer. Unless we have some friends in the at NASA that would let us use some of their bandwidth. That would be the only other option, I think, at this point, because we just don't, there's not that many big dishes around.
Yeah, Joe, unfortunately, the deep space people tend to work on higher frequencies. So there's not many people with 23 centimeter capability who also have a very large dish. But I'll keep looking.
Okay, Mark, I appreciate it. Thank you so much.
Hey, Paul,
Yeah.
one time, when I was up with Ray helping change the feed, I put my weight on the hub. You can hang on that. You can, most of us weigh around 200 pounds. You can hang on that. It's so solid. So I have not done any engineering analysis, but just by putting my own weight on the hub, it's like, well, this will easily hold 100 pounds. I don't think we need counterweights.
Well, I wasn't so much worried about that, the weight, the breaking the mounts. I was concerned about the fact that the distance from the feed to the balance point is about 30 feet. And if you take that 30 feet and take the weight of the feed and the all the other stuff that's going up there, the power lines and everything else, we're going to have about 4,500 foot-pounds of torque at the center, where it's going to be divided between those two jack screws. And in terms of horsepower, I'm not sure. I'm not a mechanical engineer, but I would imagine it takes a little bit of horsepower to move the dish up. Going down should not be a problem. And the thing is, as it is right now, I believe there is, again, this is without any data, is that I believe the dish is already weighted to be to be like going downward as opposed to neutral. But that's just my guess, and I'd leave it up to engineers.
Well, I can suggest something. Yeah, before we're gonna do something or I even make a decision on doing something, because a different angle of elevation, it would be different, stress. But what we can do, because right now there's, I think something is attached to it, but it's not significant heavy. So if someone gonna drive set the antenna to zero elevation, as close to zero as possible, and drive to 90 degrees and go backwards, back to zero, and track the current on the motor when it's empty system, and then we can simulate the weight by 100 pounds. They're putting those concrete blocks or something inside the hub to sort of estimate the 100 pounds or more, and then also track the current and see the differences. And there wouldn't be significant difference on each phase for the motor, then I wouldn't be concerned. What I meant to say is something needs to be done, and I don't know what is, but at least there are some ideas that we
Alex, can I interject for just a second?
Absolutely.
I did some testing this last Wednesday when we were down there, and first of all, let me say that the group that designed the dish and operated the dish, there was some significant weight in feed lines and in waveguides and in the feed antennas that were at the hub, probably more than we're talking about. So let me just leave that.
Yeah, we already removed a lot of that weight.
Yeah, we've taken some of it out.
All the copper feed line, 3-inch.
The other thing I can do is I'm going to share a plot. I did this testing while we were there, and to start out, it's not complete yet, but I took the clamp-on current meter and put it on the 460 volt bus. Here you can see a picture of it over here. So this is the 460 volt bus that goes into the inverters. And then we drove the dish in elevation only from the stow position down to the service position. And here's the raw data for that. And this is the plot. Now, these sharp corners in this plot are more my error in having to look back and forth between the elevation as indicated on the tower Raspberry Pi versus the current. And so if there's a little jaggedness here, that's probably, error because I'm trying to concentrate on two things at a time. But remarkably, what we find is that starting out from the stow position, it was pulling about 1.85 amps. And I believe that comes out to about something like 1.6 horsepower if we multiply everything out. And it is linear with elevation. This is elevation on this axis. That's 90 there, and that's 0 there. And it's pretty not only linear, but it's a straight line curve. And so I'm looking at this and I'm saying, okay, that makes some sense. And that would indicate that we think that the counterweight is probably heavier than the dish because we're pulling the counterweight off of 0. The other curve is going up. So it's moving up to the stow position from the service position. So here's 0 degrees and here's 90 degrees. And remarkably, that also starts out at 1.75 amps and decays down to about 0.99 amps. So that's about 1.6 horsepower down to about something less than 1 horsepower. And that's also a straight line curve. If somebody wanted to model this, that'd be a place to start. Now, we could take the dish and do more experiments with it, but what this tells me is it didn't perform how I expected it to. But it's performing in a linear fashion with a straight line curve, and we should be able to model that. I don't think that you'll need to add any counterwork.
Let me ask you this, Bill. Was using RMS?
Yes, this is an RMS meter.
Okay, so the RMS won't show the inrush current, right?
Yeah, and there's no inrush current, or well, at least I didn't see any, right? Because it's
there would be inrush current because that inrush current is what was killing the diane at those angles of elevation. So in order to capture inrush current, we need to use the something like a scope.
Different problem. Yeah.
Correct. Yeah, correct. So, but you're on the right path, and I appreciate with that data because that was kind of like a long time due to have it, and at least we have a point, which just shows like, yeah, and I agree with you that because the guys that designed the dish, in the counterweight that currently is, they knew what the weight and load going to be at the feed. And you're right. We were with the counterweight it's a lot more heavier now than the feed because even if we put diane, there's absolutely nothing. So we kind of like not balanced right now.
This is probably diane is probably the EVE is probably a drop in the bucket compared to the weight of the dish and the counterweights.
So there are possibilities that putting E25 system will be perfect balance. So that would be win-win for all of us.
Yeah, I don't know. It looks to me like the way they designed the system was to have the counterweights heavier than the dish so that it couldn't freewheel into the stops. So if you lost the brakes, or remember that this thing originally was done with a counter rotating motors and a eddy current clutch. And so if that were to fail, you'd be in a position, if the brake didn't fall in, freewheeling into the stops in elevation. And I don't think they would have designed it that way. They probably would have designed it so it would go the other way. But anyway, so there's data. I'm still confused by this data. I don't understand why going up, it does the same. It has high current at the start and low current at the end. I don't understand that. It should be the opposite.
But when it's at 0, isn't it at 45 degrees to the ground? I mean, it's at 0 elevation. It's basically straight up, right?
At 90 degrees, it's straight up. At 0, it's on the horizon.
That's what I mean.
You're not considering the
The
Am I-
weights are
am I on?
taking the momentum and raising the dish to the up position if they are out of balance.
Yeah, getting the weights off of ground zero going down to the service tower, this one makes sense to me. Going the opposite direction, it doesn't. But I'm sure if I do enough research, I can figure out what model is this. It's basically a balanced beam model. Okay. And you got a mass 1 and a mass 2, and what you're trying to do is figure out where are those in the travel of this thing in 90 degrees of the rotation.
Well, the weights are like a pendulum and they want that dish to go straight up.
Yep,
If
that's what
if
I'm
there's
thinking.
no counterbalance in the hub.
Counterbalance in the hub.
If the weight of the hub is less than the weights, the counterweights,
But it's the
counterweights
total.
are going to go like a pendulum,
Yeah.
and it's going to want to point that dish up.
Yeah, but remember that the dish itself, there's a center of gravity of the dish, and we think the dish weighs like 60 tons,
Yeah.
right? That's probably wrong. That 60 tons is probably a wrong number. But at any point, there's a center of gravity of the dish itself, not including the counterweights, and then there's a center of gravity where the counterweights are. And you got those two center of gravities, those are M1 and M2, and those are working against each other on a balanced beam. And so that has to match this current. Modeling that has to match this current because this current represents force. That's 460 volt bus into the inverter. That's the 460 volt bus right there on that red wire. And we got a linear straight line current characteristic that it should model to a balanced beam.
You can run the same test by using peak values measurements and set RMS and compare the data.
Well, that's one of the problems. We need to haul a whole lot more equipment up there to do that. And so what we'd have to have is a good current probe big enough to clamp this wire, and a current probe amplifier and a scope that we can record on.
That's
I mean, most of the clamp meters, they have a peak and RMS measurements, but I don't know which one you have, but it's all the matter of switching. But I suggest just a simple current probe that generates the voltage based on the transfer impedance, and it connect to the oscilloscope, FFT mode, or spectrum analyzer, whatever. Because we're talking a low frequency here, and just to monitor this and put in the peak value, hold the peak over.
Go ahead, Don.
You can use a Hall effect probe to check.
Well, we have some Tektronix current probe. Ray just ordered a current probe.
That's right.
Ray's got a clamp-on current transformer that we can put into a scope.
Yeah, that's the idea. Then the other thing is, don't forget, you have pretty high mechanical loss in that system.
Yep.
And I think that probably accounts for the difference in current at the beginning and end of your slope.
Yeah, this
could
just be
0.9 at the 0.9 at the top.
Yeah.
And what was the beginning current?
1.8 going up.
Okay.
Yeah.
So I think you got 0.9, you just got mechanical loss for about 0.9 of it. That's
so you're saying
it's awful high. I mean,
you're saying
good
friction.
heaven.
You're saying the friction in the elevation drive to drive
all the
it up.
drive, the drive, the azimuth, and the azimuth is just a big bull gear, right?
Yeah, so I think that's what this is. There's two components of this curve. One is friction, and the other is the lift.
Yep, exactly.
Against the two weights of the balance.
And what Alex is talking about is the inrush starting to move it. It's the
angular
it's the
momentum.
Torque necessary to get it going. Yeah,
right.
The angular momentum.
Yeah, to get off the angular momentum and also off the stiction of all the bearings.
Exactly. Yeah.
I'm pretty sure
the stiction will be okay, but and And I think the inrush will be okay too. There's nothing there that indicates, I mean, it indicates that almost half of the initial starting out at the 0 degrees, that almost half of the current that you're using is going into mechanical loss.
Well, the inrush current only will exist if you have a capacitance in the system. But if you have inductance, that's going to slow down current anyway. So that's going to smooth the inrush.
Yeah.
So the point is just to measure and observe. So we don't want to go into science study on that. But Ray was showing the amazing probe, exactly what I've been using for years and being an MIMC guy. So something like that will give us the idea, because that doesn't solve the problem why the diode shuts off on the specific angle elevation where we can hear the motor is just screaming. So why the motor screaming? This plot does not show us, Bill. So that's why there's still remaining questions that
Well, it's a variable. It's a variable frequency drive, isn't it, Bill?
Yes, it's variable frequency, variable pulse width modulated.
Yeah,
and
boy,
so,
you can't tell where the screaming's coming from.
Well, and Alex, what I noticed was that the elevation is very quiet. It's the azimuth that's screaming. And the azimuth is screaming because it's trying to command a zero speed. And
well,
it
I don't think so, because when we replaced the chain, the azimuth was completely quiet. The only noise that being generated was by elevation motor, not by azimuth. So I'm just a little bit confused about on that statement.
I found the opposite this last week.
That's kind of strange.
I was in the tower and the elevation was quiet as, of course, all I was doing was driving it down and back up in the stow command, right? So I wasn't overdriving it, but it was very quiet. But when the azimuth ran, it was making all kinds of noise. And it was, in fact, the motor would stop and it's still buzzing and cranking and buzzing and making all kinds of noise.
Yeah.
Well, I think we're gonna kind of taking time of a meeting, but we just need to put some action items, what we can do beyond that point we have. So, and just collect a bunch of data, because it's only data collection, no more than that.
Right. Ray, you have a current transformer. Did you get your current transformers? Do you have one you can hold up? Yeah, go ahead, Ray.
Yeah, I've got 3 of them.
Oh, good.
And I'll show you one here real quick. I was holding it up there, but you would.
I was on the wrong page. I'm on the wrong page here. Oh, yeah. Okay. And that'll clamp on and give us a...
Screws right there. You just open it up.
That's the ticket.
Yeah, and can we put that into a scope?
Yeah, we've got 3 of them. And yeah.
Okay, good. Nope, we'll have some more work to do.
Well, Bill, wouldn't the weight of after a certain angle, wouldn't the weight of the dish itself work as a counterbalance?
Well, does it? If this was perfectly balanced, when you got to the 45 degree position, you'd have a straight up and down current line. Your current wouldn't be changing if it was perfectly balanced. So all you'd be is working against friction.
Yeah.
But this changes over the position. So that's, when you think about it, you've got a weight on each end of the balance, and it's different. And so it ramps up. So anyway, yeah, not a science experiment, but we should understand it.
Thanks a lot for all the input, and there'll be more discussion on this, and we're getting pushing the 8:30 hour, about 2 hours.
All right, I'll get off.
No, that's okay. One thing that was mentioned in this discussion was back when this thing was operational in the 60s and 70s, there was a whole lot more stuff up there on that dish. And I would expect there's several hundred pounds, if not more, removed since DSES has taken over and removed all the copper feed line. And I think the feed horn, Ray, did we have the original, that feed horn that was removed from that dish years ago, the original one?
There are several around, and one of them's over at Steve's place. In fact, it's in the transmitter building over there, and it's like a 400 megahertz horn feed.
Yeah, it was pretty heavy, wasn't it?
Yeah, so it's about 5 feet long, I think, something like that, 4.5, 5 feet.
So that 100 pounds
And
we're putting up there's probably not even coming close to what was originally up there.
oh,
Yeah,
no.
there's no reason to counterbalance 100 pounds. I don't think there's plenty of margin in this thing.
And that goes along with the electrical proposal. We're going to run conduit along the side of the fiberglass arms. That same area had 3-inch diameter copper feed line all the way up, as well, a waveguide, as well as the original waveguide that's still up there right now. So
Yeah,
two-
that's 3 1/8 inch transmission line, right? RF.
and that was pretty heavy too. You add all that up. So I don't think that the new proposed power line will even come close to what was originally on that, hanging off that fiberglass. So I don't think that extra weight's going to be.
So I have a quick solution to that. I'm just was thinking it's a very kind of actually very simple because you can disconnect the brake, right? Is that possible? Just like
Oh, yeah.
electrically. So you're gonna set dish at 45 degrees, right? You're gonna hanging the chain or rope from the hub down, and we're gonna have adjustable weight, right? Just add 50 pounds, disconnect the brake, and if antenna goes up, that means we have a lot more counterweight than the weight. So that only one experiment mechanically will prove us that the antenna is balanced, and all we care is only 45 degrees.
Yeah, actually,
Yeah,
because of the jack screws, it won't I don't think it'll self-propagate to a high position. It'll just lock up on the jack screws.
Okay, so that will prevent the dish going to the middle. So the brake doesn't. I mean, I kind of like mechanically. Besides the jack screws, if there is nothing holds and only weight, it will just cause the friction. But there's no brakes or something.
Yeah, there is a brake on both axes. I just don't know with the jack screws, thinking about a jack screw mechanism, it kind of is self-protecting in that it'll lock up on the screw and it won't turn.
So basically, if the brake fails,
Yeah.
that means the all stress gonna go on the screws.
Yeah.
And that was intentional design to break
Well,
the screw.
well, yeah, because normally all the tension's on the screws anyway when the brake's off, right? Driving it up and down. But if
Correct.
for some reason you lost the motor and the brake wasn't there, all the force would be on the screws just sitting there.
Okay. So the screws don't.
All I'm
don't
saying
go
is it
freely.
probably wouldn't freewheel up, like I said. So thinking about the jack screws, it probably would not freewheel.
That's 100% or is just assumption.
That's just my assumption. Yeah.
No,
Okay.
I don't, there's no reason that it would freewheel against the jack screw.
That's
No
what I'm
way.
saying.
No
Yeah,
way.
It would any one of those kinds of
Right,
mechanisms
right.
it would hang up.
Right. And even the bull gear is not gonna, because it's what do you call it?
Well,
Oh, damn it.
The bowl gear could, if there's no.
No, it really can't, because driving the bull gear is a what do you call it? Single shaft driving the gear, right?
Yeah, there's a transmission between the
Yeah,
azimuth motor
yeah.
and the bull gear.
Right, and the transmission is not a bunch of spur gears. It's probably what am I trying to say, Bill? Help.
Well, like a screw gear or
yeah, worm gear.
a worm gear,
A worm drive.
gear.
It's a
Worm
worm drive, and
yeah, you
the
can't-
worm drive is self-protecting too.
Yeah, worm drive you can't. The worm drive and the jack screw are similar.
Exactly.
So that means the bottom line here, if when you move, when the brake is disengaged, all stress from unbalanced system goes to the worm screws, correct? To jack screws.
Yes.
Yeah.
So that means we warn those screws every time, not knowing as a system balance or not. Well, this is a different question, but it's kind of came up right now in the middle of conversation that not knowing what the balance is, we don't know how long those screws going to last, right?
Right. Well, and that's part of this experiment is to try to figure out, well, is it balanced or is it not?
Yeah.
I would say it isn't.
Yeah, a lot of unknowns on that.
Yeah, I agree.
Well,
I suspect, as you're saying, that in actuality, it's probably got too much counterweight
Possibly.
at this point. Possibly, yeah. I would imagine so.
yeah. I want to keep the thing rolling here real quick. I want to
Yep.
change the agenda real quick. I want to see if Bill Thomas can put his podcast information on right now to get that out of the way, and then we go roll into Bill's update for the construction as well as what he was wanting to talk about, the new engineering diagrams we discovered on the site. So, Bill, or can you jump in here?
Yeah.
Okay.
Yeah, absolutely. Yeah, I've been invited to do an interview on the W1DED Worldwide Ham Radio podcast, a guy by the name of Kevin Thomas. He has done about, I don't know, 150 of these interviews over the last couple of years. Seems to be a pretty popular podcast, gets featured on the front page of QRZ.com frequently. So he gets 1,000+ views typically on one of his podcasts. And one of the things I'm going to talk about is the Deep Space Exploration Society. I had raised the question via email to the board, and we had quite a robust set of give and take on whether I should even mention the project at this point. And I think I'm just going to take the most cautious approach, which is to mention that we have been funded for another project, and more information will become available as the project progresses, and not make any other comments about the project. With respect to the society itself, I'll give a quick overview of the history and the kinds of activities and the participation, and obviously the new building and all the efforts that Bill and everyone has put into that. So it should be a good, promotion for Deep Space. And, we'll probably get, whenever it airs, we'll probably get, a bunch more hits to our website and potentially groups.io. The actual interview is going to be conducted on December 20th. I don't know what his backlog is in terms of when he publishes. It could be several weeks or a month later. So that's the update.
This is a Zoom-like interview where it may be interaction between the both of you.
Oh yeah, absolutely. Yeah. There'll be a video for what it's worth. But yeah, he does not use Zoom. He uses a different system, he told me, that's was designed specifically for people creating video podcasts. But from my perspective, it'll behave much like a Zoom conversation.
Besides DSES, what are the topics you plan on covering?
Well, I'm actually going to start with DSES because that then kind of leads me into ARDC. So we'll talk, a bit about ARDC and what it does, and sort of its history and track record to date. And then I'm also going to probably talk a little bit about our local ham club, the Parker Radio Association. Kevin likes to ask in his interviews towards the end, sort of what your personal opinion is vis-a-vis the future of ham radio and how to make it successful going forward. And while the Deep Space Exploration Society and ARDC are components of that, I also think your local club is critical. And so I'm going to talk a little bit about our local club and some of the things it does to encourage membership and new hams getting on the air. So that'll pretty much be the 45 minutes or hour discussion.
Okay, sounds great. Anybody have any comments for Bill here right now on this subject? We'll be looking forward to seeing the results and the official date, whatever it's actually released for.
Yeah, please let us know when that's going to air.
Yeah, I'll post the information when I have that. And I think doing these kinds of interviews or promotions, obviously from time to time, is a good way to publicize the society and everything that we do.
All right, I agree. Okay, and as well, if anybody wants to get a hold of DSES IO groups, please contact Bill. He'll get you on that, point in the right direction on that, as well as any questions about the website. Contact Bill for that information. So we'll move on to the next topic. Speaking of the history of of DSES, we ran across through an email that came to the information at DSES, which goes to all the board members, and I think it even goes to you, Bill, but they were inquiring that they had some documentation on engineering drawings for the site. And, I'm skeptical of anybody that tells us they wanted information or, so I had to research them, and I think Paul did the same and Bill did the same, and we came to the conclusion that this was a legit request because they were wanting information, other information as well. So Bill contacted, so go ahead, this individual up in Boulder. Bill, you want to go ahead and take it from here?
Yeah, it's Justin Price was the individual. He's a technician with the NIST, the National Institute of Standards, and the ITS, the Institute of let's see, Telecommunication something standards, I think. And he's an archivist, and so he has access to a lot of these drawings. And here, I'll show you some of the stuff we got. Here we've got a diagram, a drawing, and the date on this drawing is like 2/28/58, I think. Yeah. And what this shows are the pylons or the piers that were poured in concrete about 14 feet deep on a footer that are the location points or the tie points for the dish. And so that gives us some insight into the structure of the foundation for the dish and what holds it down and has kept it in place and level for 70 years. And I was thinking about these, and the thing that came to mind was we've got the 30-foot dish, and we've been discussing how do we build a foundation for the 30-foot dish. We might want to examine this drawing and see if it's something that we could use for our 30-foot dish. But there's 6 of these piers, and there's a ring that goes around them that ties them all together, and the dish sets on it and bolts down to it. So that's one. Let me kill that one.
Yeah, those are what you say, 14-foot pillars in the ground for those pedals.
Yeah, they're like 14-foot. Oh, what do you call them? I said it. Not pylons, but piers.
Yeah, piers. Yeah.
And then there's a bunch of other stuff he sent us about. There's drawings of the elevator that was in the 500-foot tower that was on site at one time. And we don't need that because it's no longer there. There's also pictures of and drawings of a building that they were going to build that they never built. Let me share this one. And it's a subterranean building, or part of it is subterranean. It has a subterranean portion, like a bi-level, and then a above ground building. And this was actually designed and put out as a proposal, but they never built it. So we finally built a building.
This building was going to be built right at the edge of the foundation of the pedestal. The part that's sunk in the ground is where the dish would set when it was tilted over to the service position. And in the building itself, there was a design for the roof would open up and a lifting device would come out of the roof of that building and go up to the dish feed. So that's how they planned this, how this building was, but it was designed to set right next to the pedestal of the dish.
I was kind of curious about what the subterranean part was, and that was so the dish could come down on top of it.
Correct. Yeah.
They could probably service the dish from the roof.
Yeah.
So, and then there's what's really the treasure trove is all the pictures of the bunker. So these are the engineering drawings of our bunker. This is the ramp coming down into the bunker, the entry hallway or ramp. This is that little storage area right inside the door. And this thing here is this sump that's right outside the door, and the sump drain. And that's the drain for the ramp water that would come down, and the pump was in this area here in the middle where we now have a storage area. But we have a pump that's actually in this sump right now. You come on down the hallway, and there's the septic tank that was inside a chamber that we've had open before. And I've actually found the sewer pipes that come in and out of this septic tank. And then there was the machine, what they called the machine room, which we call the battery room, and that has the sump in the floor. And our batteries sit over here in this corner. And then the bathroom is next to that, and they had a dark room next to the bathroom. And it says dark room here, and there we can actually see a discontinuity in the floor tiles, where apparently they had actually built this. There was a wall in here, and that's no longer there. So that dark room's not there, but we have our little kitchenette in that space. And then across the hall is the storage. This door does not exist. There's a door here, and this wall does not exist. And this is what we called the hidey hole that Ed Korn and Steve Block built for the bunkhouse in there. And then the big room is where we have the radio station now and all the other stuff. So you see there's quite a bit of detail in these, and there's the elevation view of the whole thing and showing the ramp coming down and the septic tank and everything. So it shows how it was constructed. So anyway, if unfortunately he didn't have any drawings of the dish, and that's what we're looking for now. We found out that there's this company called General Bronze Corporation, and they're the manufacturers and designers of the dish. And apparently there was a problem with the specification where they didn't meet the specification. And he told me there was actually a lawsuit that was filed by I believe NIST or ITS against General Bronze, and all the drawings of the dish were entered into evidence. And so somewhere somebody has this information. He suggested, as we've talked before, maybe in the National Archives and Library of Congress, are drawings of this whole system and how it's put together. And that would really be valuable, because there's a lot of things about the dish, like we were talking about counterweight and all that we don't understand. And so if anybody's back in Washington, D.C. and wants to go on a fishing trip, it'd be great to get a hold of some drawings at this detail of the dish itself.
We had about 20 of these drawings that were given to us, 15 to 20 of them.
Yeah, there's 20 drawings, but I can share that screen. But most of them don't have anything to do with what we're doing.
Yeah, one of them's a land plot.
Yeah, there's the land plot. There's the carriage assembly of the elevator, where you see carriage that kind of goes with this elevator. There's the electrical drive of the elevator. There's a lot of stuff about the hoist and the elevator. And there's about 3 drawings of the various incarnations of the bunker, and then that new building. And but I wish we had more on the dish itself. But it's a start. Anyway.
And these were given to us by Justin, and I gave him some information. He was wanting information on the Longmont T22 2 60-foot dishes up by Longmont. So I gave him what information I had on that, told him I'd be still looking. I'm sure we got there was a lot of stuff initially on the old website, so it may be still in some archive somewhere, hidden somewhere, of some databases I may have, or may pictures. I'll have to search through a lot of the stuff I've collected over the years. And so I was real treasure to find this stuff.
So somebody wants to take a look at these or play with them.
They're in they're just Dropbox. We can send them anybody want it.
Yeah, I've got them in I copied them from Justin's Dropbox to mine, and I'll send you the link to the Dropbox, and you should just be able to open them. Just don't modify them or delete them or anything, and we'll keep them.
Yeah.
So Bill?
Yeah.
Do you have any idea of when that lawsuit may have occurred?
You know, I didn't get that information. I don't know when that occurred.
They have that information.
Apparently, the dish never really met the. He said there were experiments they wanted to do that they never really could do because of this issue, and so there was something missing or something that didn't meet the specification. We did find out that the dish was actually used. Well, anyway, the T-22 dishes, the two in Longmont, were actually used for some atmospheric experimentation to look at water and ice molecules in storm clouds. And they actually used the dish at 10.7 gigahertz. Okay, so that was a question that we had that was kind of answered by that it could go that high. The dish was designed to go from 400 to 11 gigahertz.
Good. Okay.
So there was a lot of new information there that he had, and would want to stay in touch with him and try to find out if he's got anything else that we can tap into.
And one other thing, Bill and I talked about, Webmaster Bill, that at some point, when time permits, Bill might add a historical link on our website, which will have a lot of information. May not have all these details we're just talking about, but may have a lot of pictures and additional information. That was on our former website, DSES.org, which we lost use of years ago. So that's all I got for this segment. Now, Bill, would you have anything else to talk about the construction update?
Yeah, just quickly, the electrician has been out working on the final electrical, getting all the outlets put in, all the outdoor outlets, and he just ordered the lamps for the outdoor doors. You have to have it's a commercial building, so you have to have a lamp over each door, or an outdoor light. And so he's getting those in, and he'll probably finish all that up. And then I asked him so we could get a final billing of the electrical. And part of that would be a final electrical inspection. So we'll have to get we'll have to pay the contractor or the electrical contractor that does the inspections to come out. But yeah, so
also, Bill, when people go down there and you see something that may not be working right in the way of electrical, please, or anything, please let Bill know, so we can address those issues while we still have contact with the builders, contractors, to fix anything that may have been screwed up. And also, we need to come up with what to do, what not to do plan, the opening and shutting down of the building as well.
Yeah, we need to come up with a guide, like a checklist of what you do when you come in, what you do when you go out, and make sure that things happen, like power gets shut off, air conditioners get shut off, heaters in the bathroom and the kitchen get left on, stuff like that. So and take the trash out and all those things. So checklist would be a easy way to do that. Just have it at the door. I'm going to share one more thing, Myron.
Sure.
Let's see. We want to stop that share and drop that out, and let's see. Getting confused in the shares here. Here we go. Okay, today we went down to what is a closing Amazon contract warehouse. Okay, and they're a fulfillment center, and they operated for several years with Amazon. Amazon now built their own brand new warehouse. They didn't need this one anymore, so RC Teal got in touch with let's see, what is his name? Rick. I'll come up with his last name here in a minute. But anyway, Rick Hagen, I think is the name. And he got us a tour around this warehouse, and they had all these shelves. So we took all 6 of these shelves you see here apart today, and load them on Rick's trailer. And there were other things that we got our hands on. Let's see if I can move over here. We got this table and 5 chairs that all match. They look like that one looks like a different color, and that's not the one we got all 5 of these gray chairs and that table. We didn't take these tables. I couldn't think of a use for them, and we don't have room. But we got the shelves and didn't get those shelves. We got these 2 file cabinets, and we got, I think, 3 whiteboards, 2 very large whiteboards. Unfortunately, I fell on one in the trailer because it was so slippery and punched a hole in it with my knee. But the other side of it is good. So we still got a pretty good whiteboard. That one was brand new. And then we got a workbench and what else? That's about it. Oh, and he gave us a couple of fire extinguishers.
Oh, great.
And so we got a whole bunch of stuff. I did give him some money to take his crew out to lunch because they put up with us and provided all the tape and all the stuff that we needed to do this, all the lifts and everything. So we paid a little bit for that, but we got far more value out of the process than we paid for. So all this is in Rick's trailer. He drove it back up to Black Forest tonight, and I hope he got there because he wasn't on the meeting. I don't think he's on yet. And so we should check on him tomorrow, just make sure he got home okay. And it was pretty slick out there. Anyway, so that's all I got.
Okay. Yeah, it was a good find. I was down there with helping out initially, then I had to leave as they were starting to load it up. Very snowy today, very slick roads, and Rick was really wanting to get home real quick because of the road conditions. So we got some good furniture because we had budgeted furniture in this overall building project, but now we won't have to spend as much money.
Yeah.
Furniture. So and some of those shelves we'll take, probably most of them we'll use in the new building, maybe one down at the new bunker area, but I don't know, we'll decide that when we get all the material out there on site. And so anyway, thanks a lot for any questions on that. One thing I do want to cover, I didn't have a chance to talk to Doug Lieber about this. Doug, do you have any more information about the high school tour or briefing that we talked about last time?
Nothing important so far.
Work in progress, huh?
Robin Masters has made some really good contacts.
Good.
And gotten the ball rolling. So it looks we're the most exciting thing was making connection with the principal of the high school, and who should be a real asset in getting it going.
Okay.
But I'll for the next meeting, I hope to have a lot more specifics to report.
Speaking of the next meeting, we'll have a next meeting in January. We're not going to have a science meeting due to the closeness of the holiday season. So this is our last one of the year. The next one will be in second Monday of January. We'll get information out on that. Renewal of dues is coming up for those who have paid in the past annual on the first of the year. You can start sending your money in any time. Starting the first of the year, we always put out the notice prior that we are voting of board members. This year, we're voting for 3 board members. We'll get more information out on that. So we'll decide how we're going to work that. I think it's 3 board members. I think it's Don, Paul, and Floyd. Floyd has already talked to me about not running this year, so we'll may have an open position. So we'll talk about that again, and we'll just send a letter out for open nominations for board of directors. The board of directors, once they're selected, the board of directors select the officers of the bylaws. So the general membership selects the board of directors. The board of directors select the officers. So anybody else on this? We covered a lot of topics this week, tonight, I should say. A lot of great information from Glenn and Lewis and Phil on the dish elevation issues. Ray on the new feed on the 250 megahertz feed. Hopefully you guys can get down there and start doing some pulsar work soon. Alex, a fantastic briefing on the EV25 equipment update. We'll keep everybody involved with that, how that's going on. And of course, the treasure trove of drawings we've received, hopefully we can get more information on those drawings, as well as maybe some actual dish information. I'm sure it's available. We've always said it's probably somewhere in a bunker somewhere in the archives in DC. I wish my brother-in-law was still around, because he was a guru in the National Archives, and he took me to some places in the archives that I never knew or existed, and got to handle and hold treasure troves from General or President Washington, Abraham Lincoln. He even gave me the rifle that Lee Harvey Oswald used, and I got to hold it. So he had access to a lot of stuff, and I'm sure he could have found what we're looking for, but he's no longer with us. He retired a long time ago.
They're like Nicolas Cage.
Yeah, I tell you what, the basement of the National Archives in DC was amazing. Anyway, anybody have anything else? I need to get out of here. We're 2 hours and 15 minutes into this 1 hour program. Well, I think we accomplished a lot. Thanks, Bill, for your briefing on the podcast. Looking forward to hearing that. So that's all I got. You guys can stick around and talk some more as long as you want to. Feel free. Floyd, we'll leave it open, and we'll continue on.
I'm going to stop recording.
And everybody have a great holiday, and we'll keep you posted via email and website and whatever else we can do.